to find the real zeros and sketch the graph, the first thing you need to do is figure out your P over Q. That's the factors of your constant over the factors of your leading coefficient. So for this one, my constant is 12. The factors of 12 are going to be 1, 2, 3, 4, 6, and 12. Over the factors of your leading coefficient. For this one, our leading coefficient is 3. Its factors are 1 and 3. Now remember, each of these numbers up top can go over each number on the bottom. So if I rewrite those, of course I can have all of the just regular whole numbers, or anything over 3. So 1/3, 2/3, 3/3, which is just 1, I already have that, 4/3, 6/3, which is 2, I already have that, and 12/3, which is 4. We already have that listed. Okay, so these are all my possible rational roots. Those are the ones that I'm going to choose from to see what to use for synthetic division. Now I've already done these ahead of time, so I know which ones are going to work. I will go ahead and pick 3 first. That's the number that goes in my division box. Then list your coefficients. None of these exponents of x are skipped, so I don't have to place any zeros, and it's just going to be 3, -5, -16, and 12. First thing you do is bring down your first term, then multiply. 3 times 3 is 9, and you add down. -5 plus 9 is 4. Multiply. 4 times 3 is 12. Add down. This is -4. Multiply. -4 times 3 is -12. When I add down, this is 0. If you get a number here that is not 0, you need to erase your synthetic division and pick a different number to go here. The only way this works is if you have a remainder of 0. Okay, from here you can do one of two things. I'm going to choose to go ahead and do synthetic division again. So I'm going to pick another root from here. Remember, all of these could be positive or negative numbers. And I'm just going to start my synthetic division here. The next one that I'm going to choose is 2/3. Okay, again, I've already worked these out, so I'm kind of cheating on here, but I don't want to waste your time with using all the ones that don't work. Bring down your first number. Multiply. Add down. Multiply 6 times 2/3. That's 4. If I add down, that's 0. Okay, for your last term, once you have just two numbers here, put an x here. This is already a +6, so +6. Set this equal to 0. That's the easiest way to find your last root. I already know two of my roots. They're 3 and 2/3. Okay, to find the last one, add your x, whatever your sign is here, and then equals 0. Solve for x. So subtract 6 from both sides. That means 3x is -6. And then divide by 3 on both sides. So x is -2. Okay, so my roots for this one are -2, 2/3, and 3. Okay, that means on my graph, I will put points at -2, 2/3, you can kind of guesstimate there, and then 3. Okay, the multiplicity for these are all 1. I only had 3 one time, 2/3 one time, and -2 one time. Okay, if your multiplicity is odd, it crosses through at that root. Okay, since all of these have a multiplicity of 1, I'm crossing through the graph at each of these points. The other thing I need to take into account is the end behavior. Okay, what happens as it goes to the left and the right. First thing you do is look at your leading coefficient. This is a positive leading coefficient. So the right side goes up, okay? Whatever your leading coefficient is, the sign of that, that's what the right side does every single time, okay? So because this is a positive leading coefficient, it's going up. Then look at the degree. Your degree is odd, so that means the other side is going to be the opposite. Okay, so left side is going down. Okay, if it was even, it would be doing the same thing as the right side. So the left side needs to go down. This is crossing through, crossing through, crossing through. The right side is going up.